Okay. Hey, everyone, and welcome to the SaaS developer community where we learn from each other how to build software as a service. And with me today, I have Vignesh, who is engineering manager of the database engineering team over at Cloudflare, where he's running large-scale database system. He blogged about it. I read it. I thought it's a cool system and invited him to the show to talk to me about it a bit. So, Vignesh, welcome to the show.
Yeah, glad to be here, Gwen.
Perfect. So, let's start. You're leading databases for Cloudflare. Tell us a bit about Cloudflare and what you do with the databases.
Sure, yeah, I mean that's a good place to start. So, if you haven't heard about Cloudflare, it's basically an internet performance, security, and reliability company. Probably started in 2009, and roughly we serve close to 15-20% of the internet right now. So one out of five websites. Um, yeah, that just tells the scale. I mean, I think we have a public fact somewhere like saying 55 million HTTP requests per second we process. So we started the business mostly as, if you think about it, mostly started with performance, to improve the performance. So it's a CDN, if you think about it, company as a CDN, where you can spread your static assets everywhere, and then people can get to the assets much faster instead of going to the origin servers where you have your kind of a core data centers, or where you have the assets. That's where we started with. Then we added slowly into other pieces, like improving the security aspect, right? Like, for example, SSL certificates, or web application firewalls, like application firewalls, API security. So anything that you can think of, once you have a website online, you kind of need more security. So that's the next piece which we did. After performance, it's security. But in the recent days, where the company is going more is more towards the developer tools. If you think about it, it's again, it's a cloud, different cloud, or we call super cloud.
Super
um,
cloud. I like
yeah.
that.
Yeah, it's a super cloud. So, in the sense that we trying to kind of re-architect or build things in a different approach, taking a new view, instead of always thinking about, you have your regions, and you have to think about every time when you try to deploy something, oh, which region I have to pick, east, west, continent, etc. But since Cloudflare is a global company, we don't really have the notion of regions. We run everything everywhere, every time. So it's
Everywhere,
like,
everywhere, all at once, like the movie.
yeah, right, yeah, exactly. We can do things a bit differently than other providers or players. So that's where our next bets are. It's mostly around Cloudflare Workers, where it's your functions as a service model. We have databases, D1, a SQLite database, and then Workers KV, a key value store, and what else we into now, R2. It's an object store. So pretty much what you get out of your typical cloud providers is
A-
what we do.
And all those services basically use databases that you run.
Yes, yeah, that's right. So all the pieces needs, if whenever they need any kind of metadata information, so they all connect to our databases. So that's a good segue. So if you think about it, my team provides the databases, which is basically the control plane for the Cloudflares, all the edge products that we talked about. So anything that needs a metadata, or anything that needs a Postgres database with the consistency requirements and reliability, then they reach out to my team.
So obviously, you provide services at a very large scale, and I thought it may be a good idea to take a look at your architecture. So you
Sure.
presented recently
Yeah,
at Scale.
yeah, exactly. Last 2 weeks ago. So this is typical our architecture. So nothing, yeah, nothing fancy if you think about it. I mean, it's all using the. If you notice one thing, it's all using open source components, and pretty heavy on the Postgres ecosystem. So we have like PG bouncer, a connection pooler that's like sits in front of the Postgres database. and we use HA proxy, which is like a load balancer, L4 load balancer. Then we have vanilla Postgres, no Postgres compatible databases. No, it's just Postgres, plain Postgres. Then we use uh, Stolon for our high availability. That's the interesting piece there. Then we run Postgres, and of course in multiple regions. You can see the primary region and secondary region, and even within the primary or secondary region, we also have multiple availability zones. If you think about it, right? So even availability zones are, if you think about it, like data centers which are isolated. So having one data center going down shouldn't really impact your entire region. So it's a kind of a redundancy come resiliency.
So for you, basically, you have resiliency within a region, and then you also have cases where the entire region is down, and you also have resiliency between regions. That's the kind of architecture you're
That's
looking at.
right. That's right, Gwen. Yeah, exactly.
Got it. So we'll get to more details around it, like why exactly PG Bouncer, and a lot will go more in depth into some of those components. But when we originally had this conversation, one of the things that were interesting to me is that you have over here you're drawing, only two regions, three databases in each, and so on. But you actually have all those different products that you support all of them. So I wanted to hear, how does all those different products interact with those databases, and what kind of services do you give them? Are they all together just on six databases like it looks in the picture?
Yeah, definitely. I mean, to give a rough estimate, it's like probably we maintain right now like a 15 or 20, around 15 to 20 Postgres clusters. So what we call like a cluster is basically a group of databases in Postgres terms, at least. And each cluster has like three servers, or each cluster is built across three servers in one region. So if you think about it, just one cluster is constitutes of six servers, which is split into two regions. And within that one cluster, we have multiple databases.
Got it. So in the architecture diagram, we're basically looking at a single cluster,
Yep,
which you didn't really draw the different databases in this diagram,
correct.
right? It's more of a
Yeah,
physical.
maybe a tiny one there. There's some lines or something there
Oh,
that, yeah,
yeah, makes
yeah,
sense.
yeah. But
So basically, we take this diagram, we multiply it by 15 or
yep,
50 or 15.
15, 1 5.
1 5. Okay, and this is your entire scope. And
Yep,
then within one of those, you have multiple databases.
that's right.
Um, and how do you manage products and systems between all those databases?
Yeah, that's a very good question. Yeah, one of my colleague nicely puts it. He says that that decision is more of an art than science. So we don't really have a really good formula or something. I mean, I've been getting the discussion recently to figure out where should a database should land in, right? A new product coming in, where does it goes in those servers? To the most part, it's kind of the DBAs who does the magic behind the screen. They take a look at the load, and what are the missions constitutes of, what are the other databases that are already running in them, and then what's the growth for those databases we are predicting. So a lot of manual domain knowledge is involved before we decide where a database is going to be landed on.
So I'm curious in a bit more detail. So let's say that I am an engineering manager at Cloudflare, and I'm like, hey, we have this new product that we're building. Let's talk about how I take it to production. What
Sure.
kind of questions do you need to ask me in order to
Yeah.
decide where does my service go?
Yeah, that's a good question. We even have a template that's the first thing that teams come to us. When they want a new database or a cluster, they come and request us. That creates a service ticket for us. a lot of things we ask, for example, to begin with, what's the application does. Is it going to be like storing like a system of record data, or data which are kind of, you can repopulate, not necessarily the source of truth for them, right? that's
Mm.
that's the that's the
You're
fundamental,
basically
right?
asking me, are you okay losing some data? That's what I'm hearing here.
No, 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 I mean, being a managing databases, and then you don't want to ask that question, but at least you get to know, or you want to know what you are storing, right?
Yeah.
In general, mostly things like, sensitivity of the data. Is it like user data? Is it like a PII? I mean, anything we can get to know just by asking this question: what data you're storing? Most of the time, we know whether it's a PII or not, or how sensitive it is. Then the traffic pattern, if you think about it, is it like a read heavy workload or write heavy? If you're just going to be ingesting all the time, that's going to be so much. That's an exception. Most of them, let's say 80%, it's all read heavy, but still that's good to know. Then things like, what's your archival process? You don't want to like store once and then say some kind of requirement that we are going to store them forever. Is
Yes.
That's another good example, like number of connection counts. So there are applications we have seen, they're like connection hungry. They are not necessarily doing a lot of work, but they want to hog connections. Especially
Oh, yeah.
that's a case when we are using like a third party application, right? If you write your own application, to a certain extent you can control how many connections you use, what state they are in, is it in idle mode or idle in transaction, whatnot. But then if you are just using some open source project that they have already done that, and they want just a Postgres database, and in that case we can't control some of them, because you have to otherwise basically rewrite your application.
Yeah. So basically, you take all of this, and then do I always get my own database or on one of those
Cluster.
clusters, or do you sometimes say, okay, your traffic patterns, just go use this other person's database, you'll be fine?
Yeah, that's where it leads into, right? So once we get all these questions, another one we also ask is how much data growth is, to be honest, right? If
Yeah,
you're just going to put like 100 MB, and if you're very small application, we kind of them what we call like a multi-tenant, right? Keep the database in an existing cluster, to answer your question. Then you come to and tell us that, hey, we are predicting the data growth to be like around 10 terabytes in 1 year. Then we have to think twice, because you don't want to put one massive database, and then there are like 100 other like a small and tiny databases. That's
yeah,
where I said, when it's more of an art where we have to figure out and then answer it. But basically the outcome is, either it's two outcomes: either we put them on the same on an existing cluster, co-tenant with other databases, or we decide and create a new Postgres cluster. Basically those six machines across those two regions, what you're seeing, we will spin it up, and then they are going to be the only tenant on that cluster.
makes sense. So let's say that I tell you, hey, my database is going to be very high load and I'm
Mhm.
going to be like a petabyte of data in the next year. Um, Are you going to ask me where does the money come from, or is it like all your budget? Like maybe this is too much detail and you don't want to share.
No, I mean, I think that's a good question, to be honest. Like, where does it's kind of to a certain extent gray area, right? Because a lot of the products, when you're starting up, you don't really have a lot of those great details. How much money
Yeah,
you are going to generate, let's just be frank, no one really knows. Exactly. You can only predict that it's going to be and whatnot, but you don't know. You're almost every project starts in a POC phase.
yeah,
Um, so if it's something like petabyte scale that you're talking about, then it's probably going to involve multiple teams, like hardware team, business, finance, and database team, and application team sit together and discuss, hey, what's the investment that we are talking about and whatnot before. I mean, think twice before you deploy once. So
yeah. That makes a lot of sense. So since we have you in your at scale presentation, one of the things that you really introduced in the presentation is how hard it is to run a system at the scale that you are. And you had this huge list of problems that you guys ran into. Can you share that?
yeah, that's definitely. I mean, and also I will give you a disclaimer here. A lot of these problems are, to a certain extent, is very unique to Cloudflare. One of the main reasons is we run all of our databases on our own data centers, and basically we also run them on top of bare metals. No kind of hypervisors or virtualizations. So I mean, I'm happy to go over. Let's see. Hopefully, a thing or two is more interesting to other folks. I would begin with, let's say, hardware challenges. Again, this is unique to us. For example, disk switch or router failures, network partitions. I think
Mm,
that's very
yeah.
interesting for pretty much anyone who is running in this kind of multiple availability zones and regions. Other ones are very unique. Cooling issues, natural disasters, and other harder problems. Yeah, we ran into, for example, like last year when it was very hot in Portland. There are a few cooling issues, like
This is hilarious. So your servers shut down because they overheated?
not shut down completely, but at least a part of them are impacted by it. I mean, it's just like you can see the temperature on those racks or servers are going up. Either some of them goes down or some of them starts degrading in performance. So
Yeah. Wow. So my database is slow because it's hot in Portland. Global
yeah,
warming is causing my
yeah,
database to be slow.
yeah, yeah. You can say it's running hot, so really hot.
Yeah, definitely. And what kind of natural disasters did you guys run into?
I mean, to a certain extent, even the cooling issues, I kind of consider as natural disaster because it's the global warming. That's
Yeah.
that's kind of what it caused. But so far, I mean, nothing major. The flood, for example, that had brought to almost to an extent where we have to think twice, like we have to activate disaster recovery process or not. So, but I just feel it's becoming more common now. So.
Yeah, and I mean, obviously, there are data centers in California, and you
Yeah.
never know when we'll have an earthquake.
Yeah.
Yeah, it's definitely the moment you run data centers, which Cloudflare obviously does, things get really interesting.
Yeah. Only one thing I would probably touch upon is mainly the network partition rate.
Yeah.
It's very hard to debug them. That's what I find out. You kind of figure out, hey, where is the problem? You spend a lot of time just to understand. Can you connect from here to here, this machine to that machine, that zone to this zone, this region to that region, and then finally you figure out where the problem is. Then you have to debug. So just the nature of them is quite difficult. Going back to the previous point, so this is an actual picture of it. So a smart hand
Oh,
on,
that's the temperature
yeah,
monitor.
yeah, temperature monitor on the right side, and how we, and this also helps, like you can open up some of your tails and then let the cool air come in, and that reduces your temperature.
Yeah, that's hilarious. Yeah, mitigation. We open the window.
Yeah. Exactly.
That's great. So, can you talk to me a bit about? I want to go back to the previous slide with the network partitions because it
Sure.
looks like it's hard to debug, and you guys are practicing them, right? I mean, when you say
Yeah.
practice deliberate partitions, every once in a while you cause a network partition and check if someone in your team can figure out what happened.
Yeah, exactly. That's really what I feel like, how you can manage distributed systems where you kind of proactively poke them and try to break them in a controlled manner instead of being more like reactive and wait for them to happen. So we have wrote internal version of Chaos Monkey called PG Monkey, Chaos Monkey, but for Postgres, which does a
Amazing.
lot of, yeah, a lot of things, like rebooting servers and kind of restarting load balancer, triggering a failover and whatnot. Another, as part of that, we also extended using the TC command, the traffic control command from Linux, to include more latency between our clients and databases intentionally, so you can see how the timeouts are impacting your service.
So, where do I find all those tools?
That's a good question. I haven't open sourced the PG Monkey, but part
You
of
have
it
not
is,
open source Paging Monkey.
no, no, yeah. Part of it is so tightly coupled with our setup. Probably we should make it more, generic and interface oriented.
It's definitely something that the world is waiting for. I hope you
Okay.
know that.
It motivates me to go back and remove those hard coded and then put it back. So
Yeah,
we'll get back.
exactly. How hard can it possibly be? Uh, okay, so yeah, no, this just sounds. I'm mostly expressing my admiration for your setup. So it sounds like you have an interesting tech stack. So you have the PG Monkey, and here you also mention Toxi Proxy.
Yeah, that's another good one. Shopify's Toxi Proxy. To I mean, to be honest, that I haven't or my team hasn't using it, but I just came across and I found it really cool. So if someone is looking for someone that's already open source, maybe Toxi Proxy is good one.
Cool. Any other tools that are kind of noteworthy that you want to call out?
Noteworthy tools. Stolon is a good one. I mean, if you're looking for in general to run Postgres HA, there are not many options. Patroni, Stolon are pretty much two. HA proxy we use pretty good, does the load balancing part really well. And then the PG bouncer. Probably one note to add is that we forked the PG bouncer, and so we run forked version of PG bouncer. That's available. That's there in GitHub, so you can go and see.
Yeah, and we will link. I know you wrote a blog post about
Yeah,
forking of PG
yeah,
Bouncer, so we will link to that in the show notes so everyone can enjoy the forked PG Bouncer.
sure. Yeah, absolutely. Yeah, I think that's pretty much it. Nothing other tools that stands out. PG Rewind probably another good utility in Postgres that's very interesting if someone is looking to build something like HA system.
Sorry, which one?
PG underscore rewind.
Rewind.
Yeah, rewind. Yep.
What does it do?
Uh, it's basically rewinds your Postgres database or Postgres cluster.
Like
So if you think,
replay things backward or?
yeah, yeah, exactly, replay it. So let me go back to the architecture diagram, right? So this one.
Yes.
There is a primary region and secondary region, which is
Yes.
good. And primary is replicating to the secondary region, right? I mean, this actually idea should go fit to any RDBMS. For Postgres, MySQL, pretty much everything works the same. Where you ship whether you're write ahead logs or binary logs in
Yes.
MySQL world. Uh,
Exactly.
but they are asynchronous, right? The replication between the regions are not synchronous. You don't want to wait for every acknowledgement to your client to go back. Only after you replicate your changes to your disaster recovery to a good, as a good disaster recovery has to be isolated and altogether in a different region.
Yes.
Which means we are talking about probably hundreds of milliseconds of latency,
Yeah.
200 millisecond latency or 100 millisecond latency. So that's why, in general, those primary and secondary is based on asynchronous replication. So the
Yeah.
moment we say them asynchronous, that means they both are not one and the same at any point in time. They are just keep changing all the time because you are keep writing in your primary. Let's say we have to disaster strike on your primary region and we have to promote your secondary. Well, it's fairly easy, promote in options. You can just promote them so they no longer like a read replicas. They can now you can start taking writes in your secondary
Yes.
region. The important question is what happened to your primary region. Say it comes back up after 30 minutes or 15 minutes, and then
Oh,
you
it
want
will
to
have some rights that no longer exist.
exactly you want to change the role. Now your secondary region is actually the primary region. The one used to be your primary now needs to be secondary. That means it has to replicate in other direction.
Mm-hmm.
But the problem is it can't just start replicating in other direction because it has some rights that has not yet been replicated to the secondary
Yeah.
region. That's where this tool PG underscore rewind comes into picture, where you can run them and then it rewinds. It compares your source, which is the new primary in the secondary region, and then it rolls back. So basically, it takes off some of the diff in the data.
Amazing. So, yeah. So, this is a great high availability setup. So, definitely something. And was the token at scale recorded? I think it was, right?
Yeah, it is recorded, so we can also provide the
Yeah, we
link.
link to that so people can hear the talk. You shared a lot of your high availability tips and techniques.
Sure.
Now, let's go back to where it all started, I've read your blog post about performance isolation at Cloudflare. So let's talk about. Tell us more about what was the issue.
Yeah, this is going back to our previous discussion about, okay, a new database someone wants, and where do we put them?
Yes.
Well, there are only two places. One, we can put them on a new on an existing cluster where we can just add a new database, or we can put them into a dedicated cluster.
Yes.
Obviously, the challenge with to a certain extent we can start providing each teams with their own dedicated cluster. It's not impossible, it's just more overhead, because if you think about it, we have to set up the monitoring. For example, if you keep setting up every database into a new cluster, we have like probably right now like 500 or 700 databases.
Yes.
So all of them we have to set up the
Wait,
monitoring,
so
right?
on
Because
15 clusters, you have 500 to
don't,
700 databases?
don't quote me on that exactly, but
Okay.
should be around, yeah, should be around like multiple hundreds, let's say. Like,
Wow.
yeah, it's very highly, kind of co-located or multi-tenanted. So that's where
Very much.
some of the challenges comes into picture. And what we did, or most of the work that we did around forking on our PG bouncer, is basically to solve some of those problems.
Yeah, I'm just thinking now that there must be a lot of other hard things that are hard. I mean, I memory management.
Mhm.
Like I yeah, it's anyway, let's go back to one focus on one problem, which is the one you had with performance isolation. So tell
Yeah.
us which problem did you run into?
Yeah, so what I call like a noisy neighbor problem. So the first one I would say to begin with, it's most of the clients are like connection hungry. They try to hoard client connections as much as possible. And Postgres, if you're aware of it, one of its architecture shortcomings or decision, depends on how we consider, is each client connection is a server connection.
Yes.
So
It's a
definitely that's not
process. It's a server process, and those are all
exactly
on the same machine. Yeah.
exactly. You can literally see them. It's good in way you can
Yeah.
see them, like in each client connection you can see which process it is, next process, and
You
you
can
can
do kill
treat.
dash nine if you really don't
Yeah,
like it. Yeah.
exactly. If you don't like your, some of your application developers do that, but kidding. So that's the first piece. So each client is trying to now try to get more connections, and we kind of need to keep like a gatekeeping. Hey, this is the number of connections you can use. Then the next problem I would say is kind of like a thundering herd problem. When, for example, applications redeploy,
Yes.
they kind of they
All
used
the
to be quiet.
connections at the same time.
Right, all the connections same time, and they do a lot of initializations, and they want to everything there. Like, oh, it's like altogether a new incarnation for an application if you just redeploy, and they have to reinstate their like state, whatever it is. So they have to basically like hit the database so rapidly.
Yes.
These are two common ones I have seen with respect to what we run into. Some other things like clients running a lot huge deletes, a massive delete, because it's for them, it's like they as if feel or they think that they are the only tenant, so they can, yeah, it's
Yeah.
my database, so
Of
why
course
can't
I
I
can
just run
delete everything.
it?
Yeah.
uh, I'm being a good tenant, I'm deleting my data instead of just keep storing it, so and then run like a 50 million or 5 million delete in the middle of a day, and that could potentially impact other
So do you
tenants.
also educate developers? Because like I can see that for a developer, they don't always know, for example, that truncate is much cheaper operations than delete. That if you want to delete a lot of rows, sometimes it's better to copy to the side the ones you keep, truncate everything and copy back. These kind of tricks are not things that everyone is always aware of.
Yeah, that true, because to a certain extent, or to be honest, they are not daily doing these activities,
Exactly.
and it's mostly that's where you have database engineers who keep thinking about these problems. Yeah, we do put some advocacy, if you think about it, like in like developer advocacy, where we publish best practices. How do you do schema migrations without really hurting yourself and the database. So that's a big piece. Adding columns, for example, if you're adding new, don't add some default values, because you then going to lock pretty much every rows and go back. That's going to be a huge operation. So those kind of, yes, we add some best practices, and I believe in general developers are now becoming more aware of these challenges and locking in general. So which is good.
Yeah. So you talked about all the connections and the problems that happen when someone starts all
Mhm.
those new connections. And that's why you're using PG Bouncer in general.
Correct. Correct. So PG
But
Bouncer
when
has
you,
like very few controls. Let me say, they do provide some control to restrict the number of connections, but it's not very granular. So it's just like user, and the user can be this much. But the challenge is that a lot of times clients even share the users. It's not necessarily, each application is using its own user. So that's what we built on our fork, about the ability to restrict or be more fine grained with respect to how many connections that we allow for a particular client. Then the other thing is that we also can, um, on a runtime, we can change those settings. Say for example, we provide 50 for everyone default size, but this particular application A, which is even causing a lot of problems even with this 50 connections, so we just now want to make that particular only one client to give only like 5 connections, but without really restarting the entire PG bouncer.
yeah. And that's basically what you wrote about in your blog post, that you
Correct.
detected a
Yep.
client that was noisy and
Yep.
how you build the tools so in the future you can deal with this kind of problem.
Correct. Yep. Exactly.
Yeah. And then in the same blog post, you actually, one of my favorite parts that you talked about possible ideas for future improvement. Can you share some of
Yeah.
those?
Yeah, that's the aspiration piece. We really want to get it there, because if you think about it, this is still more like a reactive approach, right? You get a problem, then you get your alerts going on that, hey, clients are waiting, or some kind of load on the server is going up, so there are some symptoms of something is wrong, and then an operator needs to come back, and they have to run these commands, analyze it, and which user to restrict, and all the pieces. That's where we thinking about using some TCP congestion algorithms like Vegas or Reno, to really detect based on how much throughput that a particular clients are using them, right? If more bandwidth is being particularly used by one client, can we automatically throttle them?
Yeah.
So
Or if they have, if I can see it happening in different ways, if they have more errors, if they're retrying more, all kinds of things.
exactly.
Yeah. Definitely. Once you have this dynamic capability, you can try all those different things.
Yeah, that would be really fun, because then you don't even need to know that these things are happening, or someone needs to wake up and do them. And even for a client also, it's not like a all or nothing. For the client perspective, the noisy client, they just feel like their application is doing slow. It's just their client who is like,
Yeah.
yeah, what is happening to my application, it's slow.
Yeah. But it's
Then they
just them now. It's not
can,
everyone.
exactly. So you kind of shifted that problem, which is impacting all other good tenants, versus you just put it back to that one bad tenant, if you think about it.
Yeah. And I would say one of the biggest challenges in performance management is really automating detecting who is the bad player. If there is
Yeah,
even bad player, sometimes you slowly go to a point where you're
yeah,
oversubscribed. But if there is a bad player, detecting them and then making sure that only they feel the consequences of their
absolutely.
misbehavior.
Correct. That's the approach we also take. Instead of protecting all the good players, that's what we try to do a lot of time. But now with our approach, we decide, no, protecting all the good players is so difficult. Rather than find the bad player and then basically, go against them, like reduce
Exactly.
their connection. So
Yes. So we're running at time. And I always like leaving viewers with a bit of advice. So if someone is trying to run this large scale, high available systems that you are, what would be some tips you can give them?
Yeah, that's a good question. So find a good HA system, like build a good HA system is what I would start with. Meaning like a good HA system. What is it, right? Like an HA system which is resilient enough for failures, and isolated in different, isolated or distributed in geography in such a way that one region or one building shouldn't basically take out your entire application. So that's my definition of a good HA system. It's fairly difficult to architect, takes at least few attempts, like it's a more of a learning process. You try different things, then there are certain failures won't even happen for a long time. So that's where the other my previous, if you go back, it's more proactive. Try out different failures yourself, and at least even in a staging environment or something. So
Yeah, like turn off the air conditioner in the data center to see what
yeah.
happens. Yeah, no, but I completely agree with you. At the end of the day, if the system is down, nobody cares about performance, nobody cares about anything. High availability is kind of the basics for any database.
True, totally.
So, Vignesh, thank you so much for joining us on the show. It's been a pleasure.
Thank you very much, man. Have a good day.